For today's chapter exam, we were told to use the last two digits of our VID. So the last two digits in my VID are 8 and 5. So adding them together, 8 plus 5, we get 13. And since there's no number 13 in the homework, I add them again with 1 plus 3, and I got 4. So number 4 in the homework states to understand how to convert between different sound intensity scales and how the decibel intensity of a sound changes with distance. The decibel scale is logarithmic in intensity. So the equation given is beta equals 10 log I divided by I0, with each of them representing transmitted light and incident light. In this formula, I0 is reference intensity, which for sounds is taken to be 10 to the power of negative 12 watts per meter squared. The constant must be used to convert a particular physical intensity into a sound intensity level measured in decibels. Once you know the sound intensity level in decibels at a certain reference distance from a sound source, the 1 divided by r squared decreases of intensity with distance can be accounted for the surrounding or for the subtracting the decibel value appropriate to the ratio of the new distance to the reference distance. In this problem, you will use the decibel scale to analyze a small firecracker that emits 1200 watts of peak power. To avoid confusion, intensities denoted by I are in units of watts per meter squared. Intensities denoted by beta are in units of decibels. So, the first part of our question asks, what is the peak intensity beta in decibels at a distance of 1 meter from the firecracker? To solve this first, we have to convert the intensity into watts per meter squared that the firecracker is emitting. So in order to do this, we would use the equation I equals P over 4 pi r squared. And filling in these values, we have P, it is given to us as 1200 watts. So it'd be 1200 watts over 4 pi, and the distance is given to us as 1 meter in the problem, so 1 meter squared, and this would equal 96 watts per meter squared. We can then calculate the intensity in decibels using the decibel conversion equation given to us in the problem, which is beta equals 10 log I over I0. So filling these values, we'll get 10 log and then 96 watts per meter squared over 10 negative 12, or to the power of negative 12 watts per meter squared decibels. And then this would equal 10 log 9.6 times 10 to the power of 13 decibels. And after converting all of this, this would equal 140 decibels for question 1. Part 2 asks us, it takes a sound intensity of about 160 decibels to rupture the human eardrum. How close must a firecracker described in the introduction be to the ear to rupture the eardrum? So in order to find this, we can invert the decibel equation and fill in the values to solve this value. So we can do I equals I0 10 to the power of beta over 10 decibels. And also we can use P over 4 pi r squared and convert that to r squared equals P over 4 pi I0. 10 beta to the power of beta divided by 10 decibels. And then slowly this can turn into r equals the square root of P over 4 pi I0, 10 beta, or 10 to the power of beta 10 decibel, over 10 decibels. Since we are given the peak power and the sound intensity to rupture the human eardrum, we can just plug in the values to get the final measurement. So we can do D rupture equals the square root of P peak over 4 pi I0, 10 to the power of negative beta rupture over 10 decibels. And this will equal, when we plug everything in, 1200 watts over 4 pi 10 to the power of negative 12 watts per meter squared, 10 to the power of 160 decibels over 10 decibels. And when we calculate all of this, we will get 0.1 meters as our answer for number 2. Number 3 asks us, will this firecracker produce temporary loss of hearing in someone who sets off and stands 3 meters away from the explosion? Momentary sounds above 120 decibels produce such loss. So if we were to calculate this, we would have to find the sound intensity of a firecracker from 3 meters away. So in order to do this, we would do I equals P over 4 pi R squared. And filling in the values, we do 1200 watts over 4 pi 3 meters squared, which would equal 10 watts per meter squared. So all we have to do is just fill in the values from before. Instead of 96, it will just be 10. So we do beta equals 10 log 10 watts per meter squared over 10 to the power negative 12 watts per meter squared decibels. And this will equal 10 log 10 to the power of 13 decibels. And then when we convert this, it'll be 10 times 13 log 10 decibels. And the final answer will be, when we convert everything together, is 130 decibels, which is more than the 120 decibels required to blow your eardrum out or have temporary hearing loss. So yes, the firecracker will produce temporary hearing loss due to it being a higher decibel than the required amount needed.